So we're going to analyze f of x equals x cubed minus 6x squared plus 9x minus 5. First, we're going to look at finding and classifying all extreme points using the first derivative test. The first derivative, which is f prime of x, equals 3x squared minus 12x plus 9. Now, critical points mean that f double prime of x equals 0 or does not exist. Well, this thing always exists, it's a quadratic, so we simply can take 3x squared minus 12x plus 9 equals 0. And we have to find all the values of x which this is true. First thing to make this a lot more bearable is factor out a 3. 3 times x squared minus 4x plus 3 equals 0. This is an equation. I can actually forget the 3 is even there, but I'll leave it in just for the sake of discussion. This does factor. This factors as x minus 1 times x minus 3, which gives you the critical points are the numbers 1 and 3. So if there are any extreme values on this function, they must occur at x equals 1 or x equals 3 or both. The first derivative test says we need to test values not at the points, but near the points. So we write a table of f prime values. In first derivative test, making a table of first derivative values. Now, the values we know are 0 or 1 and 3. You can put them in the table or leave them out. Sometimes it's nice to put them in because you kind of know where your regions are. You first need a value less than 1. I think a very obvious choice is 0. You need a value between 1 and 3. Obvious choice, I think, would be 2. The value bigger than 3, we can use 4. You can simply now make a calculation plugging 0, 2, and 4 into either the factored form or my original version here to get different things. 0 is easiest plugged in there, gives me a value of 9. 2 should give me a value of negative 3. And 4 should give me a value of 9 as well. In simple calculations, I hope they're all right. So kind of laying these out on a number line now, 1 and 3 we know are possible, they are the critical points, they're possible extreme points. Here, the derivative is positive, which means going uphill. Between 1 and 3, it's negative, which means going downhill. After 3, it's positive, so it's going back uphill. So now, at the value 1, it does change from positive to negative, which means this is a maximum. At 3, it changes from negative to positive, and it's definitely a minimum. And again, the picture makes that kind of clear cut. Therefore, by first derivative test, f has a local / relative minimum at x equals 3, and f has a local / relative maximum at x equals 1. Again, the first derivative test requires a change in the sign of the derivative. The only place the derivative can change signs is at critical points. So we take a look at the values. First, this is where it can change signs. The different regions it breaks the interval up to. Positive to negative means maximum. Negative to positive means minimum. Okay?